I guarantee 100% you're going to be assigned this optimization question in your calculus course. And I'm going to show you the answer. Let's take a look. So they phrase this question a lot of different ways. I'm going to make mine about a dog park. And you're trying to make a dog park, and one of the sides is already enclosed for you. So maybe it's a river, maybe it's a cliff, maybe it's a wall, and you need to build the other three sides of this fence to enclose your dog park. But there's a constraint, and the constraint is you only have 240 feet of material to make your fence. And in general, this is how optimization questions work. You have one equation you're trying to optimize. In this case, you want to try to maximize the area of this dog park. But you can't just make the area 1,000,000 by 1,000,000 because you have a constraint. And in this case, the constraint is you only have 240 feet of material to make your fence. And so the way we do these problems is first, you take your constraint and you solve for one of the variables. So 240 is equal to x plus 2y because you have two vertical sides but only one horizontal side. And you can solve that equation for x and you get x is equal to 240 minus 2y. And then you plug x into your equation you're trying to optimize. Your a is equal to x times y because that's your area. And then we get 240y
minus 2y squared.
Now this is an equation with one variable, so we can do our standard calculus techniques. We can take the derivative, we can set it equal to 0, and we can find out if that point is a min or a max. So the derivative of a is 240 minus 4y. You set that equal to 0, and you get y is equal to 60. We should check to make sure that this is actually a maximum. So if you do a number line for a prime, 60 is your 0. When you plug in a number smaller than 60, you get a positive derivative. A number bigger than 60, you get a negative derivative. So your function is going up and then down, so that point is actually a maximum at y equals 60. If you don't like the first derivative test, you can do the second derivative test too. Second derivative of a is just -4. That means our function is concave down. If your derivative is 0 and your function is concave down, that makes you a maximum. So again, you can see that y equals 60 is a maximum. And now the last part of optimization questions is to actually answer the question. So maybe it's asking for the dimensions of the park. Well, if y is 60, x is 120. So your answer is going to be 60 feet by 120 feet. Maybe it's asking for what is the maximum area you have. So if it's asking for the maximum area, you have to do 60 times 120 and get 7,200 square feet. It just depends on what the question is asking, but make sure you answer the question. But then you're done, and that's it. And I guarantee you're going to see this question on your optimization homework or your optimization exam or your final exam because it's a really nice question. It's not that hard, but it still does assess the ideas of optimization, and now you know exactly how to do it. If you have any more questions on calculus topics, let me know. Post them in the comments, and I'll try to make a video for you. Thanks, guys.